So today we will be covering again data sets, data frames in a lot of details. Yesterday we just touched the concept, right? What data frames are, what data sets are. So if we want to ask what exactly is a data frame, what exactly is a data frame? And we know on the very high level data frame is data set of row, right? And we know that row means some generic object, the type of this generic object will be decided on the runtime, right? So this is data frame. But if we want to give some type to this particular data set on the compile time, then we will call it as a data set. So if data set has been assigned some type, let's say orders, I'll show you in practical, then we will call it a data set. So data frame is data set of row, and particular data set is data set of some type. We need to define that type. What are the benefits of data type, data set? That data sets are compile time safe, right? You will have more control when you do the programming with data set. The good part about data frame is so basically one more important thing. So when you work on data set, right, what is going on, that you need to, your Spark program needs to convert them to data frame. If you let's say if you have a data set, right? If you have a data set and you need to convert this thing to a data frame. So obviously it's not as seamless as it seems, because when we go for the conversion, there will be some encoders which will come in picture, which will convert your this particular data type or the object type into generic type, or maybe something specific to the Spark, right? So let's cover that thing quickly. So when we talk about type safety, data sets are compile time safe, data frames are runtime safe, like they're runtime safe, right? When we talk about immutability, both data sets and data frames are immutable because obviously everything is well. When we talk about schema, we need to give schema for both data sets and data frame. The good part about data frame is we can infer the schema from the data, right? If we talk about performance, data frames are more performant tunes because Spark can do a lot of things on your behalf with the data frame. When we talk about programming language, data sets are only compatible with two languages, that is Java and Scala. Why? Because they are compiled type languages, because these are compiled type, and data frames are compatible with all the languages, R, Python, Scala, and Java, because they are interpreting or runtime languages, you can say. If we say lazily evaluation, both data frame and data set are lazily evaluated till the time you don't hit action. Everything will be added to a logical plan. Whenever you hit action, logical plan will be converted to physical plan, right? So there will be logical plan, and if you hit a action, it will be converted to, when you hit action, it will be converted to physical plan, right? As simple as that. If we talk about serialization, so serialization is something, data frames are, in simple terms, they are serialized, means stored in form of objects, and data sets are stored as form of bytes. So what is going on when we want to read data sets, they needs to be deserialized and then they will be read, right? And that's where the performance of data frames are higher than data sets, right? And again, the data sets came later in 1.6, data frame were there in 1.3, and obviously RDD is the basic. One more important thing which I need to cover, everything behind the scene is RDD. Everything behind the scene is RDD, okay? Okay, this is good. Let's jump into practical now. And let me cover one more thing. In Spark 2.0, right, there's something, a unified entry point came, which we call Spark session, right? So before Spark 2.0, we have different context if we want to interact with different things. For example, we have a Spark context for generic things. We have SQL context when we want to do some SQL kind of thing. And we have Hive context if we want to do some Hive context. If we want to talk to Hive, or if we want to process some data in Hive. What happened in 2.0 version, these people made it simplified, and they have wrapped it up, everything into Spark session. Right? As simple as that. So let's jump into practical now. Today's class will be more of a practical. So if we go here and let's do one thing. Let's create a new Scala object. Okay, and let's call it Spark practical, right? And let's finish it. So what we'll do here, we'll import org.apache org.apache, okay, and dot Spark. And why I'm telling you here, it's important, then dot SQL. And from dot SQL, we're gonna be starting Spark session, right? So what we did, we imported org.apache, and from Spark SQL, we imported Spark session. Okay, now what we need to do, we need to use this Spark session to create a Spark session for us. So let's say we create a well Spark, name of the session, and let's say we use Spark session here, dot Spark session dot builder. So we use builder method, right? And then we'll say dot, and then we will say master, and master we will say, let's say local. Local means I want to use local, I want to use all the codes, right? And then we will say dot, and let's say if I want to, let's say get or create, right? So what I did, I created a Spark session. This is a Spark is a Spark session, and in this Spark session, I used the builder object, which will build the Spark session for me. I used all my codes of this laptop, and I used that as the master, and I created it, right? And let's say I want to now, going further, I can use this Spark to do anything. So for example, let's say I want to go for Spark context, right? So what I say, well, sc is equal to Spark dot Spark context. See, as simple as that. Now, whatever we want to do with whatever we were doing with Spark context, we can do with SC. If we want to create Spark SQL context, then we'll say SQL is equal to Spark dot SQL context. As simple as that. So this SQL will become our SQL context, right? Now, and this is, I'm not going to use this, but I'm just showing you this concept that in Spark session, everything is like encapsulated. Every context is encapsulated inside Spark session. So it's a common entry point to your Spark program or your Spark cluster, right? So now let's say we want to read some file, and the file name is order.txt, right? So we go here, and what we'll do, we'll say while orders, and then I will be using Spark only. So I'll Spark dot read, right, and dot spark dot read dot option, right? And in the option, if you see here, what I want to show you here, in option, you will have multiple types of variation. If you want to go for this thing, then here you will have key and value will be Boolean. Okay, so let's say we want to do some infer schema, just for timing, right? Infer schema, and the value will be true. It means the file which I want to read, infer the schema from that file, right? Let's put this thing into a separate line, and we'll say dot option, again the same thing, and I'll say infer schema, and then if let's say if I into this file orders, what we can say, we have header here, right? We have header record. So what if we want to say header is equal to true, we'll simply say header, and we can say true here, right? And then what we'll say, dot, and we'll go back again and come here, dot format. Now what's the format of this file? This is comma separated. I'll say CSV, right? And I'll simply say load it. Okay, one more option is option path. Path, comma, I'll copy the path from my previous program. So here, I'll just copy this. Okay, so I'll just copy the path. And when we go here, what is this? Data frame reader. Till now, it is not a data frame. We are still reading the data. Now, to make it data frame, I'll say dot load. Now, when we hover over it, it will be a data frame. As simple as that, right? So let's say if we want to see the data, like what is there in orders. So we'll say orders dot show, right? Order dot show, and it will come inside here. Okay, so this was good. Till now, we have what we have did till now. We have read the file from this particular path, and then we have tell this Spark that okay, the file has header. The file, you need to infer the schema from the file content itself, and the path of the file is this, and the file is CSV, right? And then what we want, we need to show the data. Let's do one more thing. When you are starting this Spark application, it's started, so it's a best practice to stop it. So Spark dot, you'll say stop, right? So stop the application, right? So let's run it quickly. So we'll go here. Yeah, one more thing. Again, I'm repeating the same concept. When you go here and you want to run it, you are not seeing any Scala application because there's no main class here. So to make the main class, we'll say extends app. Now, when you go for the run again, you'll see Scala application. Why? Because app has by default put a main class into your Scala object. So when we run it again, when we go to Windows, show view, I need to show for console. So we'll say console here. Okay. And we'll bring it here. Yeah, it's running. So what I want to see, that my files should be shown here somewhere to me. And meanwhile, let me do one thing. Import org dot Apache dot log 4j. Okay, and dot you can say level and logger. So I need to import two things, and dot logger. So let's see whether we have received the data. Yes. So what we can see here, so we can clearly see here that my file when I read the file, it is clearly using the header is equal to true. That's why we are seeing header into a result, right? And let's say if this infer schema worked for us. So to see the infer schema work for us or not, let's say we need to say orders dot print schema, as simple. And to do one thing, that we don't want to see this stupid info, right? So what we're gonna be doing, I will do copy paste from here. So this is just a copy paste thing. So what I did here, I'm just suppressing all the other issues, right? So when I run this program again, run as Scala application. So what it will do, it will only show me the required data, what I need, okay? So let's see quickly. So what we have done so far, we have read the file, we have inferred the schema, we tell the Spark that, okay, the first row is header, and then we see the data. By default, the show will only show you 20 records. Only show you 20 records. The default functionality is 20. If you want to go for, let's say 50, we can show 50 here, right? So let's see. Okay, perfect. So it came. So by default, it gave us 20 records. We can change the functionality to 50, whatever we want. And we can clearly see that it inferred the schema for us. It inferred that order ID is integer, date is timestamp, cust ID is integer, order status is string. As simple as that. Okay. Now, one more thing which I need to tell you guys, and here I explain in detail. Data frame is what? Data set of row, right? Behind the scene, data frame is a data set, and behind the scene, everything is RDD, right? So let's prove this concept. So we'll go here and copy paste one line. So I need to see the class of that application of the data frame. So I'll say this one. I just copy this path. And what I'm doing here, just to show you guys that this type of data frame. So what I'm doing here, to get the class of any object into Scala, you will be using get class object, and I need to print it. So ideally, this type of data frame should be data set. Let's see. So I'll run it again. So what it should come? It should give me, ideally, it should give me type of the data frame is data set, some org Apache Spark.data set, and it will prove that behind the scene it will be a data set, right? Let's see. So this, then it will be proved that data frame is nothing but data set of row, and I will show you that what row means. Okay, so what we seen here, the type of the data frame, which class it is, the class org Apache SQL dataset, right? So we have proved it. Now, as I was explaining it to you, data frame is nothing but data set of rows. So if I go here and I put a type here, that this is nothing but data set of row. So what it says that it is, one second, data set, well, okay, so I need to say Control Shift O. So what I did, so it was complaining about the data set is not available. So I just press Control Shift O, and what it did for me automatically, it imported data set for me. So in your Scala ID, if some libraries are missing, there's, for example, row is missing, right? Row is missing. If I say Control Shift and O, it will ask me, okay, which row you want to import? I'll say this one, org Apache Spark SQL.row, and this will be gone. So this is gone, right? So now if I run this program, so see what I did, behind the scene, Spark is doing this thing for me. But if I want to do this explicitly, then also the same result will come. Nothing will be changed. So this two things has proved that data frame has nothing but a data set of rows. Okay. Now this is good. Let me prove one more thing, that data frames are not compile time safe. Let's prove that thing. So when we say orders dot filter, right? Let's say we want to give some filter condition, and we will say here, let's say order status equal to, and I'll say complete. Okay, so I'm just pulling everything which has complete into it, right? And I'll say dot show. For a time being, I will comment this just to make our results look more concise. So I'll go here. When I say show, what it will show me, it will only show me orders which has complete status into it. Let's see. So ideally what I did, I just did order status is equal to completed. I did some condition into it, right? And if it works, then it will only show me the complete orders. Meanwhile, okay, so it worked and it shows us complete order. Everything is working fine. But let's say if I put order underscore status underscore number here. So into our file, do we have order underscore status underscore number? No. But do we see any error here? No, because data frames are not getting compile time type check safe. Like they will now, when I run it, it will fail. But do we see any error at the compile time? No. When I run it, it will give some error that okay, order underscore status underscore num does not exist into the table or into the data frame. But it is not compile time safe, right? And this is why we need, if we want to have compile time safety, we need to go for data sets. Okay, now let's create one data set. To create a data set out of a data frame, you need two things. The first thing is your case class. So I have already created one case class here. So this is our case class, right? So what it gave, let's go here. So it gave us some error, and the error is that cannot resolve order underscore status underscore number. And it's right, because order underscore status underscore number is not present in my columns. My columns are order ID, date, cust ID, order status. And by mistake, I put underscore number at the end, and it failed. But it didn't fail at the compile time. So let's see how to convert your data frame to a data set. Okay, so we'll say here, we create one case class. Okay, what it is saying that okay, timestamp is not present into it's not getting resolved. So we'll say Control Shift O again, and we will import this timestamp, and this error should be gone. So this is gone, right? And when I say Control Shift O, it directly imported Java SQL timestamp for us. Okay, and now what we need to do, we need to convert our orders into a data set. So to convert your orders into a data set, you need to say orders dot as into this. You need to give your case class name. So my case class name is orders underscore cc. But if you see here, and maybe capital orders underscore cc, orders underscore cc, still it's not working. Why? It is saying orders underscore cc is not there. Why it's not working? Because to convert your data frame to a data set, you need to import something, and that import should not be coming from org Apache. It should come from your Spark session. So what we'll say here, Spark. I'll use my Spark session. I'll say import. Now from Spark session, I'm importing Spark dot, and I'll say implicits. Spark dot I am, one second, dot one second, guys. So my variable name is Spark. Okay, and I'm importing. Let's comment it for a minute. I'll say spark dot implicit is not coming. Let me see the code which I was working. So ideally it should work because this was working. So if I say here spark dot implicit, it's working. I'm not sure why implicit was not coming. And when I uncomment this line, so this is working as well. So let's say we store this into orders underscore dataset, and we'll call it val. Okay. So what we did here in these 2-3 lines. So first of all, we have orders. This is our data frame, right? So when we hover over it, this is dataset of row, right? So it means this is our data frame. When we hover over it, this is dataset of some particular type. And what is that particular type? Is Spark practical dot orders cc. So when we go for orders, order is dataset of row. When we go for order dataset, it is dataset of some particular type. That type is Spark practical orders underscore cc. And again, this point has been proved that dataset is nothing but dataset of some particular type, like Spark practical order cc into our case, right? So this is proved. Now let's prove one more thing. We said that data sets are compile time safe, right? So let's prove that thing. So we'll say orders underscore ds, and we'll say filter dot filter, right? The good thing about this filter is we can have x dot cust id order id. We cannot, let's say we will go for order status, right? And when I put anything wrong, what it will say? Order underscore status underscore num is not a member of this particular data set. It gave us compile time error. It won't, like the program won't run. Now the question arises, is this filter function, this type of filter function available in data frame? Let's see. So our data frame name is orders, and it's a filter, and we'll use the same thing. X implies, so first of all, let's correct it. In fact, let's comment it, right? And we'll say X implies, and when we say X dot, we are not seeing the column values because at this particular time, it don't even know what column exists into this. It will came to know the columns on the runtime, and that's where data frames are not compile time safe. I again proved it, right? So we know that data frames are not compile time safe because it don't know what is there at the compile time, right? So if we say again order underscore ds here, and now if we say dot, we can clearly say columns here. But in case of these 4 columns, right? Cust id, date, ID, order status, we won't see this column into data frame, right? So let's say if we want to go order status is equal to, and we'll say complete, and then at the end we need to say show and put here, and we'll comment it so that it won't get confusion, and we'll run it. So this is how we have proved that data frame is nothing but data set of row, and data frame is not compile time safe. Data sets are data set of some particular type. Into our case, that particular type is class cc, right? Order cc. And now data frames are, in data frame, we cannot use any other column other than the table column. It means they're compile time safe. Okay, so let's run it. It will give us the same result. Perfect, it worked, right? And it gave us exactly the same result. Now let's do one more thing. Let's say we don't want to infer the schema. We don't want to infer the schema. So right now, when we say print schema, it is converting everything, to the real schema, real data types. But let's say we don't want to infer the schema, right? And we run it again. So if we don't infer the schema, by default, everything will be string. Okay, by default, everything will be string. So this is, and one more thing, let's do one more thing here. So by default, this job should be running on your local host 4040. So right now, there is no such element because the application has been closed, right? So if we go here, it says, one second, guys. If you are starting up Spark, please wait up till it's ready. One second. Let's run it again quickly. So when I go here, I can see some job should be here. What I did wrong. Let's see, if you are starting up, failed to get the application information. If you are starting up Spark, please wait a while until this is ready. It is working and seems like it's not working. Something is wrong. Let's do one thing quickly. Let's put one more line so that we can see the application won't be stopped. So what this line will be doing for us, we will put this line here. And what this line will do, this line won't close this Scala application and it will wait for some user input to close it. Let's do it. So let's run it again. And then go here, localhost 4040. Is not working. Still it's coming. So let's see if it's working for us. Yeah, it came. No such element. If you are starting a Spark, please see if you're ready. Status is 500. Strange. It was working 2 minutes back. So let's do one thing. So not sure whether this will help, but let's see. Not sure what's going on. Let's see quickly. This time it worked. I'm not sure what happened here. So I just removed this line. Okay, anyways. So till now what we have seen, that if we, in fact, let me remove this line, right? So I'll just remove this line and I'll keep that line here. What I wanted to show you guys, that now let me run it again. Okay, before I drop that, right? Let's go here. And now let's go here. So what we have seen here, that it has 3 jobs. The first job, and I have explained it yesterday as well. The first job is for reading a data set, right? The second job was for inferring the schema. And the third job was to show the data to us, this one, right? Now, since I have removed the print schema, infer schema, ideally, how many jobs should be there? 2 jobs. Let's see. I stop this application and I'll run it again. And we will refresh this page. So it's still running. Let's refresh this. Yeah, it came. Now, what we have seen, let it run and refresh it again. So it's still running. That's why the jobs are not here, because the application is still running, right? So what it's saying, cannot cast. Okay, actually what the problem is, let's do first refresh here. So what was going on, that to prove one thing I messed up other thing. So let me do one thing quickly. I will say, and I will comment these particular lines, okay, and I'll uncomment this line, and now I'll run it. So now it should give me two jobs. What I'm going to prove you guys, that print schema itself is an action. Okay, so it's running. This is very strange. Okay. Orders is equal to this. Something is getting messed up. Let me run it again. So basically we came to know that how to convert data frame to schema. We need to create a case class. Then we need to use that case class inside as operators of the data frame. So we'll say data frame as, please convert data frame into case class using convert data frame into data set using this particular case class. And we have proved that, okay, these are I'm not sure what was wrong, but yeah, let it be. So when I go here, I can say only two jobs are here. Why? Because I have removed print schema or infer schema. And that's where, if we want to give schema to it, if we still want to give a schema to it, there are multiple ways to do it, right? So let's do in some way. So there are two ways to give schema. The easiest way is to infer schema. But let's say if you have millions of rows, if you have million or billions of rows, that action will take a lot of time. So if you know the schema of the file, it's always beneficial that you give the schema by yourself. The most easiest way to give schema to your data frame is this way. So what you can do here, you can create a well. Into your well, you can give the schema and the data type. Let's say int, string, cust, whatever you want to give. And then you can say here dot schema, and I'll say easy underscore schema, right? Yeah. So when I run it again, so when we see here, right now, since I have removed the inferred schema here, it is string coming. And if I want to give my own schema without inferring the schema, I need to give that schema by myself. So what I did, I created a string of all the schema types, right? I stop this application again and I run it again. So it will give me, this is the most easy way to give schema to your data frame. But from interview point of view, they will surely ask you what are the other ways. So the tough part and the tough way of doing the same thing is using this. And this is called struct type. So I'll explain it in 2 minutes. Then let the data come. So when we see here, now our data has schema attached to it, right? Cust ID is integer, order date is string, cust ID is integer, order state is a string. So in this way, the schema has been assigned to us, and we haven't inferred the schema. The other way to infer the schema is using the struct type. right? And in struct type, when we see here what we have given, the data types are Java specific data type, right? Or Scala specific data type, int, string, all these are primitive data type. But when we want to use struct type to give schema to a data frame, then we need to use Spark data types. So Spark data types are nothing but a wrapper over the primitive data type. Integer is a wrapper over int. String type is a wrapper over string, right? And that's why we need to import them from Spark libraries. Okay, and that's why we need to import them from Spark library. Just to import, what is it? Control Shift O again, right? What it is telling me that okay, you need to import org Apache Spark SQL type structure. Yes, I'll go next. So I'll just select it and I'll say next. And from that, what I need to import? I need to import string type. I'll say next. And then from struct field, I'll say next and finish. See, everything is gone, right? Why? Because I have imported from SQL Spark integer type, string type, and struct field. Now, if I want to use this schema, it is nothing, just copy paste, Control C, and where we have used the easy schema, I'll say schema orders, and I'll run it again. I stop this application quickly. I'll run it again, and it will give me exactly the same thing. No difference. This is the easy way of doing it, and this is more programmatic way of doing it. You know, so this is how you can give schema to your data type. Okay, as simple as that, without inferring the schema. And as a programmer, you need to work toward this. So the more work you do, the less work your machine will be doing. So it's always beneficial if you know the schema, just do it. You know, just give it to him. So if you see here, it again gives us the same schema: order ID, integer, string. And one more thing which is notable here, although we have given integer type, it converted it to integer, string, and string, right? This is how it works, right? So this is how it works. Now we know how to give schema, how to not infer schema. Let's do one more thing. Let's say, yeah, the very good example is, let's say we want to count number of orders, number of type of order into from the orders table. What we're gonna be doing? That's simple, right? So it's orders dot select, and we will say which order status. So we need to select order status, right? I'm just showing you one example. You can practice at home. So select orders, this, and dot, let's say we want to group by with the same column, let's say order status. And then we need to say dot count, and let's see. Okay, and dot show. Okay, this is good. Let's try to run it. So what I'm doing here, I'm selecting order. I just want to see how many times order came. Okay, each order came into my orders underscore txt file. So it's the same thing what I did here using RDD. So this test.scala. So to do the same thing, what we need to do, we need to read the file, right? We already did. And then we need to file using space or some comma. Then we need to convert them into pair RDD. And then using the pair RDD, we need to go for each reduce by key, this one. Like, to do the simple thing, we need to do so many things. Here, what we did, we just write one line and it gave order to us. See this thing, right? So this is how you need to do operations in data frame, right? Now, let me see what I'm missing. So this is covered. One more thing, let me show you guys. So let's say what we are reading here. We are reading here CSV file. Now let's say I want to read a JSON file, right? It's super easy. What do you need to do? You just need to say, in fact, let me copy it so that it won't get messed up. So I'll say copy here. And let's say if I have this file as JSON, right? I have one file as JSON. I'll remove this. And I have one file for the zip code for the JSON, and I'll save it. I want to read this file. What I'll say, well, zip. In the good part about JSON file is schema is inbuilt into it, so I do not need the headers. Okay, I do not need the schema. The format will be JSON. Okay, and the path is yeah, the path will be here. Zip code.json. It's not under temp, so it's just zip code dot JSON. Okay, and I want to print a schema of zip now. So I say zip here dot print a schema, and I don't want these parts now. I just comment them, right? And this is good. I don't want the class now. I'll comment it, and even I don't want this as well. Let it be. Okay, so let's run it. I stop it again. I'll run it. So ideally, what I'm trying to show that it's super easy to read files of any type from using Spark session, right? So what I did, I just removed some parameters and it will work for us. So what I did to read the JSON file, what I say spark.read format JSON and then path and zip code.json. And then I'm printing the schema. And the good part about JSON file is the schema is inbuilt into them. So it will print the schema for us. Perfect, it did, right? And to see the data, what will say? Zip dot show. And it will show the data for us, not a big deal. Now the thing is, let's say if my JSON file is good now, so let's say my JSON file is corrupted. How JSON file works, so in JSON file, you have some key and value. So zip code is 704, zip type is standard, city is park, Parag, something, and state is PR. But let's say if I put some random values here, I saved it, okay? And I want to read this JSON file now. What's gonna happen? Let's see. So right now, my JSON file is in good shape. So it will give me everything. Okay, basically, when program was running, I saved the file in between. And I wanted to show you this, guys, right? So what it did for us, obviously my JSON file has 4 columns: city, state, zip code, zip type. What it did, it created a new column, corrupt underscore record for me. So it didn't rejected the file. It created a file for me with some corrupted record. It says, guys, this record has some corruption. What corruption? We don't know, but it has some corruption. Okay. So now, there are few ways. Some people, as per the requirement, might want this thing. Some people might want to say, no, if there's one corrupted record, please reject it. Some people will say, okay, use the default functionality. So the default functionality is, we will call it permissive. Okay, let me go here. And so what we say here, the mode of the reading of a file, by default, the mode is permissive. Okay, so let's say if I just put one option here, I'll say option permissive, and I run it again, it will give me exactly the same thing. By default, the mode of reading a file in Spark session is permissive. Okay, so permissive means if there is corrupt record, create a new column called corrupt record and put the corrupt record into that. For all the valid column, please put null into it. That's we call permissive, right? Now, one thing is, let's say if we want to fail the file, even if a single corrupt record is there, we'll say fail fast. Okay, so it's permissive is almost same. Without, if we skip this mode, even the same thing in the default functionality. If we put with permissive, it's there. Now, if we put fail fast, right, what's gonna happen? It will say that, okay, guys, your file has some corrupted record, so I'm failing it. Okay. And the most important thing is drop malformed. I'll show it in two minutes. So fail fast means it will fail the file. It won't read it. Okay. Meanwhile, let me paste it here. Drop malformed. Okay. So it failed. And what it says that, okay, there is some separate name value field. Something is wrong in my file. This bracket is not there, but it failed the file, right? So it failed the file because our file is not into the proper format. Now, the last mode is drop malformed. So what it will do? It will drop the record which are not in the proper format. Okay, let's see. So it will drop the malformed record for us. Okay. So what we have covered that when we want to read the file, there are three modes. The first mode is permissive. It means it will accept all the records and create underscore corrupt record or something and put corrupt record there. This is the default mode. The second mode is fail fast. It will reject the file, right? The third mode is drop malformed. What it will do? It will drop all the records which are not in proper structure. Okay, so let's go here. What it did, it read the file and it haven't read the file, the record which is not in the proper format. So it dropped that record. Okay, so this is the option of reading a file. Okay, so let's go now. Okay, so this is good. One more thing which I need to cover here, right? So you can put any type of file here when you want to read it. So always keep your coding standard generic, right? So there are multiple ways to read a file. Let me do one more thing for you guys. So let's say if I want to read a file, right? So I'll give val zip underscore new is equal to spark dot read dot, and I say spark dot read dot json. This is the other way of doing it, right? Spark dot read dot json, and I'll say this path. There are multiple ways of doing things, right? But which way we need to adapt? The way which is more flexible, more I can say modular. So I think this way is more flexible. You know, if you want to go for CSV file, we can say CSV here, right? We can put some paths here, and we can put some different options here. But if you want to, if we have only one type of file, we can go for this option as well. Okay, so this is the thing. Now, what we do in any particular program, right? Why we are doing this thing? Why we are reading a file? Why we are transforming it? So that we can save the result somewhere, right? So what we did, we read the file, right? We did some transformation, and then obviously we want to save this file somewhere. It means we want to write this file somewhere, right? So let's say in fact, let's comment it for 2 minutes. Let's say if I want to from this zip file, I want to go for only where zip code type is equal to standard. I don't want to go for unique. I want to do this transformation, right? And I want to save that file somewhere. So I'll say zip dot filter filter, and then I'll write the condition here quickly. What I'll say, zip type code is equal to standard, and then I'll say dot write, right? I want to write a data frame, write dot, and which mode I want to write. So I'll say or which format I want to write. So I'll say format. Let's say I want to, this is JSON file, right? I want to write this JSON file into CSV. So I'll say CSV, right? Then I'll use options here as well. So let's say in options, I want to save this file. In option, I want to say path, and I'll say path should be, let's say the path should be here. Okay. So I'll open this. In fact, let me copy the path from here because I need to put double colons, right? So I'll just use this path for time being. And I'll say path equal to this. Okay. And let's say I want to create a new folder called JSON. And in fact, let's say CSV. Let's say zip CSV, and I'll run it. So what this guy will do for me, it will read the file, it will filter it, then it will write the file with some options, right? And let's run it. So what it will do, it will go here, and when I refresh it, it will create a new directory for me here, because obviously I'm working in my workspace, Scala practice, right? So I have a Scala practice package here, and I'm creating some file here. Let's see. Meanwhile, let me refresh this and see how it's working. Let's go to the backend, color practice, code.json is here. And what I did, I created a path, Scala practice, zip.csv. Okay, let's stop it for 2 minutes. One second. Okay, let's do one thing first. Let's see whether our result is coming. Okay, so I'll say dot show here, and I will do one more thing. I'll say I don't want this thing, I don't want this thing as well, and let's run it just to see whether this condition is correct. Okay, zip.filter, zip code type, and then I want to see. Okay, result is coming. Dot format, it should be there. Now let's see quickly. I'll copy this code from here. Write mode, option, path. One second. So I'll say dot write. Okay, dot format. Again, I'm doing the same thing. And let's say I want to say dot format. CSV, same thing. Dot option. Is there something wrong here? So just remove something here and let's see. Let's do one thing. Since I don't want to see the UI now, I'll remove it. Save it. I'll refresh it. Just one more second. Let's run it now. I'm just dropping it. So let's see. So it's not working. Not sure why. Let's do like this. So let me run it again. I'm not sure why it's not working. Let's see. The thing with Windows is sometimes this path is create issues, Let's see this time. Workspace, Scala practice. One second, guys. Refresh. Let me remove this format for once and let's run it. Control Z. Just one more minute. Let's say Json. zip.write.parquet, or else I'll use another option. One second, if this don't work, okay. So this is the last time I'm trying with this option. We have other option as well, and I'll figure out why this option is not working. Okay, one second. So I'll say refresh, and so seems like this is not the out file. Okay, so we'll say close. Okay, now let's try one more thing. Why it's not working, I don't know. I'll figure it out. I'll say write again, and I'll say write dot JSON or CSV. Let's say I want to write it as CSV, right? CSV, and I'll say some path. Let's say zip CSV. Okay, and I'll say run it now. I need to figure out why it's not working, guys. It should work, but that's not working. But let's see this part. Now go here. I'll refresh it. Still running. It's time. Take time. Yeah, this time it worked. I'm not sure why it was not working. So it created a CSV file for us. And when I open this file, it will be all the records in the CSV format for all the standard only, right? So what we had into this zip file, we had all the records like different type of zip code type. But now what I did, I filtered the standard one and I saved them as a CSV file. I will figure it out why it's not working, but there are multiple ways of doing it. This is one of the way. I was trying the more generic way, but I'll figure it out, guys. Okay. This is all for today. We'll see you on Monday then. Okay. Thanks, guys. Thanks for the time.